In our PLM group here at Ruckus, I cover a variety of different things, but what I'm going to actually touch upon today is our couple of our virtual different products that we actually have. The virtual Smart Zone and the virtual Smart Zone data. Actually, let me jump forward a little bit. Here we go. So we have about 20 minutes or so. If you guys have any questions, please feel free to jump in. I'll try to answer those as much as possible. But the two different solutions I'll be talking about today, at least briefly, are it's jumping forward. The two different solutions I'll be talking about today is the virtual Smart Zone, which is basically a product offering we actually had come out last year. It actually is a virtual appliance that we actually use from a wireless LAN controller perspective. And also coming out soon is the virtual Smart Zone data. We'll be covering that in terms of how those two different products work together. And also, if time permits, and if you guys have some more questions on that, we can also jump into part of some virtual networking integration ideas in terms of how to basically take our appliances, use those with virtual switching. You have some options with Open vSwitch, and also have some other options with other SDN components as well. We can actually use the whiteboard for that to go into some more details. But first of all, how many people here actually are aware of our Smart Zone platform? I've actually heard about it. I understand actually how it works. So the Smart Zone platform actually was introduced, I think, at the beginning of Q2 of this year. And basically what the foundation behind that is it's actually a combination of several different controller platforms we actually have. We have the Smart Cell Gateway, which is our large-scale carrier-class platform. Very, very strong from an architectural standpoint. We also took a combination of our Zone Director and Smart Zone 100, which actually is used as part of our enterprise functionality. We combined the features of each one of those and brought those into a single virtual appliance. So some of the features that actually come out with this virtual appliance, the virtual Smart Zone, is the scale, where we're actually able to scale up, in a sense, very large scale, up to 30,000 access points, 300,000 clients. But this is actually a scalable appliance, which basically means is that the amount of compute resources you put on it will actually help determine the amount of capacity. So you can start off as little as 100 or less APs, and as you add more CPU and memory, you go up. You can actually reach up to 30,000 access points. Very, very flexible from a deployment model, and we'll actually talk about that in the next slide. Redundancy, there's a built-in active clustering, so we can have a single node deployment or 2 nodes for an active clustering up to 4 nodes. This actually is an addition to the hypervisor high availability that already exists. So if you're familiar with VMware, for example, they have high availability underneath that. So if a node goes down, you're actually able to power back on those VMs onto a different host. That functionality also applies here. And the same thing also comes up with, say, for example, AWS auto scaling groups, high availability with Hyper-V and Azure as well. So very, very flexible platform from that perspective, ensuring we actually have redundancy in place. One of the most important parts from my perspective is actually the APIs we actually have available. So starting in the release of the Smart Zone platform in 3.0, we actually start to introduce RESTful APIs into the platform. These are very, very rich, and so pretty much what you can do in the UI and the CLI, you can also do through the APIs. So if you are a larger enterprise, carrier, MSO, or basically a customer who wants to be able to do more automation and workflows, you're able to use the APIs as part of your provisioning, part of your automation, configuration, etc., or integrating with third-party devices. This actually is also very, very important if you're now starting to stack up things with the virtual platform as well. So now you can automatically deploy your virtual appliance, you can automatically configure your wireless LAN clients, your zones, etc., using the APIs. And if you actually want to go even farther, you can also branch those APIs into other solutions that are actually out in the marketplace. Distributed deployments, so from an overall a product perspective, AP survivability is a core part of the overall Smart Zone platform. I mentioned beforehand that the options for, because we actually do have a flexible scale, there is actually options for deploying into a small scale enterprise, as well as a managed services perspective. So now we can also either have a single tenant deployment or a multi-tenant, multiple services deployment. The tunneling options we'll kind of talk into a little bit when we go into the Smart Zone data. Those tunneling options, there's the option for local breakout, there's the option for using our Smart Zone data, which we'll jump into, as well as third-party products. Now, in terms of the controller solutions, in terms of where things will be fit in, it's basically a single platform, a single virtual appliance. You can scale down to work with all sorts of different enterprise scenarios, whether it be warehousing, retail, education, hospitality. Those are a couple of the different options that are actually available for us. That will be very similar to what you'd see with the Smart Zone 100, which is a physical appliance we actually have in place. The scale from that perspective is typically between below 100 up to 1,000, and if you actually want to use clustering, up to 3,000. Over in the far right-hand side, which is where the Smart Cell Gateway came into play, MSPs and MSOs are able to, and managed service providers are able to use that appliance and then deploy again from the low number of AP counts. You work your way up to 10,000 access points as well as 300,000 access points. This all comes from one appliance, which actually is very, very unique. So depending on the situation is, you can deploy it into any environment that you actually see fit from a wireless LAN management standpoint. Also from a platform perspective is our flexibility. Flexibility from a private cloud and a public cloud standpoint. We started off initially with supporting KVM and VMware on our initial release. KVM management standpoint, you see very, very strongly in upcoming markets, and also with OpenStack. And VMware already has a very, very strong hold in terms of the overall marketplace. That transfers over into the public cloud as well, where we actually see in the VMware vCloud Air Network, you're able to actually deploy that solution into a vCloud Air Network. We're also available in the VMware Solutions Marketplace. So if you basically want to go onto the VMware Solutions Marketplace, download the appliance, deploy it, you can have a trial for 90 days, be able to do a test from that perspective. Coming out very, very soon, we actually will also have support for Microsoft Hyper-V, as well as the Azure platform. GCE is already present. Then after the Microsoft solutions come into place, we'll have Amazon deployment. So in a sense, our single appliance that we actually have here covers all sorts of different environments from one single appliance. We have enterprise, provider, public cloud, and private cloud. Any questions on so far, or are we okay? From a data plane perspective, so we started off with the virtual smart zone in terms of a deployment, running off commodity off-the-shelf hardware, KVM and ESX. And with that, we basically introduced the other component of the overall solution is the virtual smart zone data, or what used to be called the virtual data plane. So what ends up happening is that this actually is a solution based on DPDK. So we actually have a lot of flexibility in terms of where we're able to deploy and able to use that. Some key aspects of it is that tunneling at scale. So based on the number of resources you add to the appliance, indicates the overall amount of throughput. So you can actually deploy to a very, very small environment and can limit the amount of resources for the amount of throughput. Or as you see fit, as you start to scale up with more APs and more clients, you can increase the number of nodes, or you can actually increase the number of CPUs. Different tunneling options depending on the overall architecture. So this actually makes it flexible from that perspective as well. And also site level QS and policy controls. And by the way, from a deployment perspective, one of the options that comes into play from a customer standpoint, this slide actually basically breaks it down is that we have two different modes from the virtual smart zone in terms of actually how it's deployed. We have a high scale version, which is labeled H, and we have what we define as an enterprise version, which is actually labeled E. In this particular situation, what we actually have here is we have an AP, and we have three different options that are actually available for the clients to be able to tunnel back. The first one is actually a local breakout, which came when we actually first released. Also, part of that was you have the ability to tunnel into your partner's gateway. And the third option actually comes into play with the tunneling to the virtual smart zone data. This actually is something that from the virtual smart zone data perspective, see if we can actually talk about this part and coming up. Actually, I'll cover it here instead. So one of the options from a deployment perspective is that we've actually seen from surveys and talking to our customers, there's actually been a lot of different options in terms of actually how they wish to deploy. In some cases, they want their controller back located in a primary data center. They want the ability to tunnel back to the data center or basically tunnel out from the access network itself. We actually provide the ability to be able to allow them to be able to deploy actually how they want to do that. You can actually deploy multiple nodes from this situation as well. So in this situation here, we actually have it set up, and I may actually do this on a whiteboard in a few minutes. We actually have the core network, which is where the primary data center is located. In there, we have the virtual smart zone. It's actually running a controller, managing the APs down here, and all the traffic is actually being tunneled back into the virtual smart zone data using Ruckus GRE. There's also the second option is that the end user had another remote data center where they actually want to be able to do tunneling remotely. You're able to provision that as they needed. Both the virtual smart zone, the controller option, and the controller option itself, as well as the virtual smart zone data, are horizontally and vertically scalable. So we're actually not just limited to one node. We can actually have multiple nodes scale up. The benefit of actually having multiple nodes scale up is that you have the availability of having multiple data planes actually available. You also have the overall capacity to be able to handle that. So we can actually have nodes deployed in the access as well as a primary data center. You can also have the situation come up to play where you have the virtual controller also deployed into different environments.
Is there any compute requirements from a hardware perspective as far as the various platforms you run it on in order to achieve scale?
It's actually a good point. So what we end up doing is that actually it might be easier if I just draw this. How do I move this? I can use that one. So one of the things we did from a deployment perspective is that each platform has a little bit different configuration in terms of how they work. Okay. In general, what we end up doing is that from let's say VMware and KVM, we basically had a situation come into play where we would scale. So this would be number of CPUs, for example, and this would be number of APs. And what we end up doing for each platform, we actually would go through and set predetermined points in terms of what you would need to do to be able to set to get your number of APs, number of clients. So we did this with VMware and KVM, with say Azure and GCE. We actually take the instance size that's actually appropriate for that and test that out as well. And say that if you run, for example, in AWS, it would be C3 large, for example, or C3 extra large. That would be a situation where this could actually handle 2,500 APs if you put this configuration in place. And we also give you different requirements in terms of storage requirements, in terms of this number of IOPS you need for this configuration. So there's a very detailed guide in terms of what you actually need to be able to do to go into that platform.
So each platform would have its own different set of requirements. The AWS requirements at scale X is not going to be the same as...
They're roughly equivalent to each other. So the private cloud configurations that we actually have with, say, KVM, Hyper-V, and VMware, we give you the baselines in terms of what we actually test with. So we'll say that we're testing with a Xeon 2.6 in this configuration. Here's the generation of the CPU. Please map it to your associated hardware if you actually want to be able to adjust that. We provide that guidance in our Getting Started guide in our materials. Okay. So we have a rough platform that actually shows from a private cloud perspective. The public cloud depends on where you're deploying from availability zone perspective. Like AWS, for example, would have different CPUs running in different availability zones. They haven't completely upgraded. So if you deploy in the east versus west, you might get different performance levels a little bit. And we indicate that from a documentation perspective. But it's one of those things where as they start to move and upgrade their hardware, you'll actually get better and better performance by using that system. Okay. But we do include your networking requirements. What's required from the AP to the controller? What's required between the two different nodes in the controller. So what will end up happening is that, let's talk about you have two different virtual smart zones. We give you the requirements in terms of bandwidth required here. So let's say, for example, you want to deploy these into two different zones or two different data centers. You want to know what the requirements are for that. And the same thing also applies to the APs themselves. So communication going backwards, and also with the data plane as well. So each one of these modular components, they kind of plug and play together, and we actually provide requirements in terms of what you need to be able to do that. Does that answer your question? Or?
It does. When you start talking about encrypted data plane through virtualized appliances, right, that obviously brings a whole host of questions about how are you offloading, how are you achieving performance at scale in a virtualized world, all of those things. So, yeah.
Right. And with that, when you start talking about the virtual data plane aspect of it, there's different modes you can actually do. You can go direct I/O, where you're basically doing pass-through right into the interface. You can also utilize the virtual switch itself.
Okay.
So not everybody has the flexibility to actually be able to use or dedicated interface port.
Not every platform has the same.
True, right, exactly. So what we end up doing is that you have two different options that are available. You can do pass-through, go directly to the interface to get the best performance by doing that near line rate. But if you can't do that and you have to use, say, an Open vSwitch or a VMware standard switch or distributed switch, you still get significant performance on actually doing that. A little bit, it's going to be less than that because you have the overhead of the hypervisor and different pieces, but you can still run it. And if you have a situation where, let's say you have, you're an enterprise, you have multiple different sites. Those sites may not have all of the extreme hardware you may have back in the primary data center. Well, now you can run on standard switch. You can run on a very basic vSwitch to have functionality that you wouldn't normally be able to have. So if you were deploying, it's an option. A lot of our customers actually have virtual hardware. They have virtual environments in place. They don't always want to have another appliance be able to rack and put in place. This gives them flexibility without having to have those requirements.
Perfect.
All right.
So do you find many customers are moving more towards Amazon or a public cloud hosting rather than on their own
It's
gear?
actually really mixed. It's actually really mixed. So I've actually seen, in a sense, all three different environments. I've seen situations where customers, whether it be education or enterprises, are all doing private. I've seen also customers where they're all doing public, and mostly managed services from that perspective, and also the hybrid scenario. So one example would be is that there's a customer that will actually uses Azure for most of their local services, but they use Office 365, they use other public cloud services to actually help supplement that as well.
Are there any feature limitations between a virtual controller and the physical controller?
There's two different modes in terms of what you're able to do. The feature limitation is that the physical controller has a built-in data plane into it, okay. And we actually separate that out intentionally because we actually want to give the flexibility in terms of actually how you do that deployment. But from a feature limitation, they are pretty much like for like. Okay. So you are able to deploy a virtual Smart Zone 100. You are able to deploy a Smart Cell Gateway 200 in a virtual appliance form factor, but they both exist on the same appliance. So when you start the process of doing the installation, you can choose what you want to do. I want this suitable for an enterprise. This is how I want to deploy it, and you can choose those options through the setup.
And this may be my ignorance of the platform, but when you talk about centralized data plane versus localized data plane down at the AP, where is your boundary of what you can bring centrally back from a data plane perspective versus leaving locally at the AP? Are you doing it per SSID? Are you saying, X user can have centralized data plane and Y user on the same SSID has local data plane?
So I'm not sure if somebody else in here can actually answer that question, actually, because I know we have rate limiting that's actually available from an SSID-based and a zone-based, but I'm not sure if we actually have that on a per-client basis.
Right. So right now what we have is a per SSID-based tunneling. So you can choose guest network, for example, to get tunneled out somewhere else so that it can be gone directly to internet or run some firewall services. If you want your employees to go through if you have a different cloud provider that does some kind of other content filtering, and you can tunnel that traffic to do it. So that's where the virtual Smart Zone -D becomes a very interesting point for people to statically configure them and point them on a regular basis, or if they can use the tools in the cloud environment, they can spin this up on demand and then point the tunnel to it. And so it can be a programmable. So that's basically what, if there was more time, we could have taken this to the next level. Is really software-defined networking is something that you step up the moment you separate out the control plane and data plane, and then allow them to spin up in a cloud environment for move.
Which actually is part of the, so there's, Etsy has a set of standards that are actually coming out with as part of network functions virtualization, or NFV. That's part of the premise for us also doing the effort to go to more towards a virtualization form factor. One of those requirements actually is to make it much more modular, to make it much more flexible from a deployment perspective. And that's where that comes into play as well. That's why you also see a separate control plane and why you see separate data plane, because you may deploy them differently. If we were looking at, for example, I'll give you an example in terms of where that would fit in. Let's say, for example, we have a virtual switch. This could be a bridge, a virtual bridge, or whatever you want to call it. There's different ways this can actually fit in place. Within that, we actually would have a port group. You have the virtual smart zone actually in place. Let's see if I can give you a quick example of how this would work. You have virtual smart zone data. From that perspective, let's give you a couple different options with this. And so basically with the virtual smart zone data, you have two different NICs that are actually available. One is actually for the control, so you want isolated control management between your controller and your data plane. The second one is actually related to all the backhauling of traffic, which actually would go to, let's say, a different virtual port group or a virtual port. From that perspective, there's a couple different options we could do with this from this perspective. We could actually add additional services on top of that. This could be a firewall, this could be some sort of security services or additional pieces on top of that. By having this actually as a virtual appliance, you can easily deploy those on demand as needed. So I could use, say, a service that comes from Ruckus. I can use a third-party service that we have a partnership with and build that in line as part of the chain. And let's say I have the firewall, I have another port group. This would actually connect to that and go out to the internet. So there's a lot of flexibility from a deployment perspective in terms of actually how we manage that. From my previous experience, I was seeing this a lot more and more with enterprises and carriers, especially when it comes to multi-tenant configurations. You want to deploy the service that the customer is actually requesting for. So they may deploy an environment, they want a firewall service built into that, then you can sell them additional security services if you're actually offering that as part of a managed services perspective in terms of where things would sit into play. So this would come from a virtual switch. In theory, you could actually push this up farther and use it from an SDN perspective. A lot of the principles actually apply from Open vSwitch, NSX from a VMware perspective. Other controllers also fit this model as well. So you're now able to use the APIs to configure each one of these internal port groups, as well as the interfaces that are built in. You can configure those from a throttling perspective, when they're up, when they're down, and also use the APIs from the smart zone and the data plane. And this actually is just localized in one data center. That if you wanted to get even more extreme, you could actually have other data centers, and you'd have an overlay sitting in between those, and you're able to also have different services built into that as well. So there's actually a lot of different options you could do once you have the virtual appliances in place. And you can deploy these virtual smart zone data, or you can do a local breakout, depending what the situation is. Which actually is very important. So this overlay could be part of SDN, it could be VXLAN. There's a lot of different options from that. And this really gives larger enterprises and service providers more flexibility.
Great, can you make that simple?
I can make that simple. I can give you a lot of details in terms of actually how to do the deployments. Especially when it comes to working with SDN, different switch vendors and things like that. There's a lot of options you can do, especially from a provisioning standpoint. I mentioned early on our APIs being, they're very, very rich. I mean, really the functionality you have in the UI and the CLI is available in the APIs. Using those APIs with the upper level, virtual networking components and provisioning, it makes a huge difference in terms of managing your environment. And this can really improve the overall networking experience for the end users. Okay, any more questions on that, or provisioning, sizing?
I was just wondering about, you've got the APs talking directly to the virtual controllers there. Is there a possibility of separating the data plane, so when you're moving the controller with something like vMotion from one data center, say, to a DR data center, you're able to move all of those APs with that?
So you want to do a migration of the VM itself, like say
you're in a failure situation where you had a highly centralized model with the controller in the centralized data center, and you're in a failure situation where you're moving that to a DR data center. Will the APs be able to know about that without doing some sort of redundancy state?
So, I'll give you an example of how this could work. That's a good question. So I'm going to actually have two different sites actually lined up in here. The APs themselves will actually have a list of the virtual data planes actually built into that. So this would be, let's call this virtual 1, this is virtual 2. So they actually would have the list of which ones are available built into the AP itself. So if the first one actually goes down, as marked here, it'll basically switch over to the second one and tunnel traffic back to that second
So
second
it'd have
location.
tunnels to both already up and running, so it'd just be able to switch
So
over.
it'll have a primary and secondary. So if this one goes down, it'll fall over to the second one and start actually using that one.
Is there an actual failover scenario for the data? I mean, it's sending data out one connection.
So is there actually, so let me see if I understand your question correctly.
Yep.
There's two different scenarios that can come into play. The first one is that if the node goes down, if the virtual data plane goes down or the controller goes down, there's a heartbeat amount of time in terms of it actually tells it, the AP will actually switch over to a different one. That's one aspect of it. With the hypervisor in the cloud, say AWS, you have an auto scaling group. It's also going to recognize that the VM is actually down and re-provision that someplace else.
Right.
So there's two different situations that are happening, and both will occur at the same time. So the AP will recognize that. I can't remember if this is 90 seconds or if it's 60 seconds before it actually goes to the second one. Then what actually happens is it's going to mark that down and switch over to this one itself. When, let's say, VMware High Availability or Auto Scaling Group recognizes that this one's down, they'll re-provision that VM into a different location and come back online. So now that AP is actually available also, that IP is actually available also to tunnel back, but it'll actually focus on the second one until that one goes down or you push it back over.
Yeah, so what I was trying to get at was more if there was an interruption for a client, so say the client's streaming YouTube, for example, through that AP,
Right.
if there was going to be an interruption to that data stream for a while it failed over from one to the other.
The switch over from the first data plane to the second data plane is short, but I can't remember if it's 90 seconds or if it's a smaller amount of time in terms of how long that will actually happen. So in theory, there could be an interrupt depending on what the situation is, but I can't remember what the exact time limit is.
Okay.
Now, are there layer 2 requirements between those data centers, or can I have those routed with different IP schemes and those types of things in each data center?
So each data center, there are layer 2 requirements, but if you're using an overlay, then you're going to have an L2 over L3. You have those configurations in place. You'd have to have a way of actually managing those flow tables. VXLAN has an option for doing that. If you're using, say, Azure, you might have a different way of actually doing that, managing them independently. So there are requirements for actually being able to do that. So there is communication requirements, especially from the controller itself to the data plane. There is a requirement to actually have the controller recognize the data plane itself. So all these solutions that we're talking about operate in a cluster format. And so basically what I mean is that you will have multiple, these are the virtual smart zone controllers. This cluster of virtual smart zones has a cluster of virtual data planes. And they all kind of interact with each other. When one goes down, the other one will actually pick up the load and be able to handle that. So there is a requirement for communication across those different nodes in the cluster. And actually how you do that can be all layer 2 on one subnet or one situation, or you can actually use an overlay to be able to handle that as well. Does that make sense? Does it help?
Nope, that answers.
Licensing on the vSZ is who can answer a licensing question?
Yeah,
It's
go
at
ahead.
995 MSRP, is that right on there?
It's $995 MSRP for the smart zone. And there's also additional licensing per AP that you actually put on top of that.
Just making sure.
None for redundancy, correct?
Yeah.
Well, redundancy is actually built into the platform.
Yeah.
That's so you get built-in redundancy. You get built-in software redundancy at the virtual controller level. If you want the additional functionality from a platform perspective, there's usually the vendors will actually have a licensing fee for that. VMware has it indirectly as part of Enterprise or Enterprise Plus. They'll include the high availability solution built into that. So you indirectly pay a fee for that. Auto scaling group or different features, you pay a feature for that as well. But as part of the platform itself that we have, that we control, the virtual smart zone, it's included. It's built into it. It's basically just a level of how much additional availability or redundancy you want in the platform.
So for environments that have a robust virtual environment, why would they ever want hardware controllers? I mean, what do you see? I know there's a lot of answers to that, but what do you see as keeping people on hardware versus the virtual controllers? I mean, why not just dispense with the hardware and make this the way? You know what I mean?
It's a good question, but different customers have different needs in terms of what they want to be able to deploy, and we actually provide them those different features. They can still purchase a zone directory to use that. They can still use a Smart Zone 100. They can use our virtual appliance. these options are available for the end user to be able to work with.
Yeah, but I guess what I'm saying is a mindset and a culture. Why, what's it take to get past the hardware? And so much is going to VM. What's
Virtual.
keeping people?
Right.
I mean, everything, even routing is going to VM. What's keeping people on wireless hardware when you've got these robust virtual options out there?
So I can answer that we are seeing more and more people actually migrate over to virtual hardware, especially from our platform, the Virtual Smart Zone. We're seeing very, very good adoption from a customer standpoint and been very, very satisfied with actually using that. In some cases, it's new technology to them. They're used to running their web apps, they're used to running their typical data center workloads on a VM. And moving over to virtual networking, it could be a new environment for them. It is very stable. Our platform has been around for years. We just took that concept and applied it to a virtual form factor and plus some additional features. So a lot of that really is learning how things operate and actually how to build it together.
Yeah.
Even from an SDN standpoint, this is new technology to a lot of customers. They hear about it, they learn about it, but a lot of them are still adopting the technology. And we feel that we're actually ahead of the game from that perspective, that we're actually building into that trend. So it's much more forward thinking from that perspective, but you'll see a trend going up with more and more customers using a virtual form factor. And
Let me add just a slightly different perspective to it. Our capacity and scale on our software controller is identical to the hardware controller. So we give the flexibility to the customer. So those who have a very comfortable virtualized environment, they're picking it up in a big way. The APs don't have to change. We have the same 1,000, 10,000 per node scale. You can cluster it to 30,000 APs, identical from a hardware version.
So asked differently, how long before Ruckus stops spending R&D dollars on hardware controllers?
How about we answer it this way, that we take standard hardware and put our virtualized software on it for those who like a metal.
Okay.
And one of the things I
going
like
that
to point out internally is that we talk about scale quite often, but this is economical down to a very small deployment for those small organizations that just have VMs and have chosen to do virtual. $1,000 list price for a controller is less expensive than our smallest controller, and it makes sense. They can build their network from there. So this is not just a huge scalability play. This is small customers who like virtualized.
This group within Ruckus is totally into software. So we totally want to convert everyone into a software when you don't need a hardware.
Is this something that you're able to purchase and put into your own VM environment from Ruckus today?
Correct. You can download for free with just a standard support login to try it out for 90 days without even paying any money.
And it comes with a free AP license, so if you want to do
Single
basic
AP,
testing.
right?
The single AP license, it comes with it for 90 days. And so you can go ahead and test it and run it on your platform. It comes with different options, an OVA, a raw file, QCal. So you can move it around to different platforms and test it out and see what you think of it.
Even